For decades, the story of Sentinel Shield existed in two parallel histories: the public legend of the 1984 bullet hitting a bullet, a testament to American know-how, and the classified tragedy of a system that never escaped the laboratory. It wasn't until the early 2000s, under pressure from historians and through declassification reviews, that the full data from the program began to seep into the public domain. A new generation of physicists and engineers, unburdened by the political pressures of the Cold War, analyzed the data with modern computational tools. They modeled the 1984 test not as a singular event, but as one point in a vast probability space. They ran Monte Carlo simulations, varying every parameter by minute realistic degrees: the exact chemical composition of the upper atmosphere that night, the humidity at the Kwajalein radar pads, the minuscule wobble in the target's deployment, the precise calibration drift of the kill vehicle's infrared sensor, which was later found to have been at the very edge of its tolerance. The results of this forensic analysis, published in dry academic journals, were the final, quiet epitaph. The 1984 success was a statistical freak. It was a point where hundreds of independent variables, each with a wide range of possible values, all aligned just once at their most optimal point. The atmospheric density was exactly as modeled. The sensor calibration, though drifting, had by chance compensated perfectly for an unmodeled refraction effect. The target had deployed in the one orientation that presented the most ideal infrared signature. There was no solar activity. The cosmic ray flux was at a historic low. The probability of all these conditions occurring simultaneously was calculated to be less than 0.3%. It wasn't a demonstration of capability, it was the winning of a cosmic lottery. The system had not, as the narrative claimed, failed after working once. The truth was more profound and more tragic. It had never truly worked at all. The one glittering data point of success was an outlier, a mirage that had seduced a nation and consumed a fortune. The machine had been built to achieve perfection in a universe that tolerates none. The bullet hitting a bullet was not a prophecy of a secure future, but a beautiful, incredibly expensive fluke, a masterpiece of engineering that solved every problem except the one presented by reality itself. In the end, Sentinel Shield stood as a colossal testament not to human ingenuity's power to conquer physics, but to its limitless capacity for hope and for self-deception when staring into the abyss. The conclusions of the Red Team report landed in Washington not with a bang, but with a suffocating bureaucratic thud. Copies, bound in black covers and stamped with strings of cryptic code words, were hand-delivered to secure vaults within the Pentagon, the White House Situation Room, and the offices of key Congressional Oversight Committee chairs. The reading of it triggered a silent, cold-sweat panic that rippled through the highest echelons of national security. The scale of the investment was staggering. By 1987, over $30 billion, a sum equivalent to hundreds of billions today, had been funneled into the Strategic Defense Initiative and its crown jewel, Sentinel Shield. This wasn't just money spent on research, it was capital invested in a future. It had funded sprawling campuses for aerospace contractors, entire new subdivisions in mountain towns near radar sites, and the careers of a generation of physicists and engineers. More importantly, it had funded a narrative. President Reagan's vision of a protective shield had captured the public imagination. It was a story of American ingenuity triumphing over the bleak doctrine of mutual assured destruction. News magazines had run illustrations of lasers zapping missiles. The successful 1984 test was played and replayed on nightly news broadcasts, a symbol of national hope and technological supremacy. Now, that narrative was revealed to be a house of cards. Admitting the fundamental flaws of Sentinel Shield meant a cascade of unthinkable consequences. Politically, it would be a humiliation of historic proportions. The administration would be accused of squandering billions on a fantasy, of misleading the public, of weakening America's strategic posture by chasing a mirage. Diplomatically, it would unravel years of complex negotiations with the Soviets, who had taken SDI deadly seriously and had used it as both a bargaining chip and a justification for their own massive weapons build. Militarily, it was an admission of naked vulnerability. The grim balance of terror, momentarily thought to be tilting in America's favor, would snap back with a vengeance. The nation's cities would once again be naked under the glassy stare of orbiting warheads. The meetings that followed were not about solutions, but about containment. In the White House's treaty room, under the stern gaze of historical portraits, advisors spoke in hushed, urgent tones. "We cannot unknow this, but we can control who else knows." The path of least resistance, the instinct of any large, powerful institution facing catastrophic failure, was to bury the truth. The Red Team's findings were classified at a level so restrictive that even most four-star generals didn't have access. The report's conclusions were rewritten in vague, anodyne language for Congress. Discrimination challenges remain a high-priority focus area for future development. System reliability in stressed environments requires further testing. The brutal binary truth, "it doesn't work," was translated into the gentle, endless continuum of ongoing technical challenges. The Sentinel Shield program was not killed. It was placed on life support, redefined. The goal shifted subtly, almost imperceptibly, from creating an impenetrable national shield to developing a technology base and deterring adversary innovation. The funding continued, though it became more opaque. The public facade had to be maintained. To cancel it outright would be to admit the failure, to invite the very political and strategic storm they feared. So the machine kept grinding, building components for a system its innermost architects now knew was a tragic illusion. By 1989, the Sentinel Shield program was a ghost ship, sailing on under automated controls while the crew below decks knew the hull was rotten. Pressure, however, continued from a Congress wanting to see a return on its monumental investment. A final, comprehensive demonstration was scheduled. It was a Hail Mary, an attempt to generate a success dramatic enough to reset the narrative, to justify the next tranche of funding, to prove the skeptics wrong one last time. The test, designated Frontier Sentinel-1, would be the most ambitious yet, involving a more complex target and a longer-range intercept. At Kwajalein for Frontier Sentinel-1, the atmosphere was funereal, a stark contrast to the electric hope of 1984. The engineers went through the pre-launch checks with the grim proficiency of mortuaries. They knew the odds. They had seen the Red Team reports. Many believed they were participating in a ritual, not an experiment. The launch from Vandenberg was flawless. The target, a modified Peacekeeper missile bus, deployed a sophisticated cluster of objects, including a live warhead simulator and advanced decoys designed by American engineers to mimic the latest Soviet intelligence estimates. At Kwajalein, the interceptor roared a light on schedule. Telemetry was perfect through first and second stage separation. The kill vehicle separated cleanly. Its cryogenic cooler brought the seeker down to operating temperature. For a few heart-lifting moments, it seemed the old magic might return. The kill vehicle acquired the threat cloud. It began its terminal homing phase, its tiny thrusters puffing, making the minute adjustments to steer itself towards the calculated point of impact. Then, at an altitude of 220 miles, near the very edge of the atmosphere, fate intervened with a mocking impersonal cruelty. A minor solar flare, undetected as a significant threat by space weather monitors, had occurred 48 hours earlier. It had sent a stream of high-energy protons sleeting through the solar system. This wave of cosmic radiation arrived at Earth's magnetic field at the precise moment the kill vehicle was performing its most sensitive operation. A single high-energy proton, a subatomic piece of stardust, tunneled through the titanium shell of the kill vehicle and struck a critical memory chip in its guidance computer. It was a single-event upset, a known but poorly understood hazard of space electronics. The proton's impact flipped a single binary digit from a 1 to a 0. In the arcane language of the machine code, this changed a benign instruction into a catastrophic command. The computer wasn't frozen this time. It was fed insanity. The kill vehicle interpreted the garbled command as an instruction to fire all its lateral thrusters at maximum duration. Suddenly, instead of making delicate course corrections, the vehicle was thrown into a violent, spinning flat spin. Gyros overloaded. The infrared seeker lost its hard-won lock on the target cloud, its view a madly whirling blur of stars and Earth limb. Telemetry to the ground showed a horrifying spectacle, rotation rates climbing past anything survivable. The delicate optics shattered. The computer, trying and failing to correct for an error it itself had created, finally succumbed. In the Kwajalein control room, they watched the data lines go static, then disappear entirely. The kill vehicle, a tumbling, useless mass of ruined precision, succumbed to atmospheric drag at the lower edge of its orbit. It began a slow, fatal descent, glowing red, then white-hot, as it carved a brief, brilliant scar across the upper atmosphere before vaporizing completely. It had not come within 100 miles of its target. The silence this time was different. It wasn't shocked, it was resigned. The mission director simply took off his headset and laid it on the console. There were no angry outbursts, no tears, only a profound, exhausted emptiness. The universe itself, it seemed, had cast the final vote. Even if they could solve the software, beat the discrimination problem, and placate the politicians, they could never control the sun. Their technological cathedral was built on sand, and the tide had come in. Within months, in a series of closed-door budget hearings that garnered no press attention, the Sentinel Shield program in its original form was terminated. Funding was reallocated to more promising ground-based research. The public was told the program was evolving and entering a new phase. The language of obfuscation, perfected over the previous years, was used to give it a quiet, dignified burial. The vast infrastructure remained, a monument to ambition, but the soul of the project, the belief that it could actually work, was extinguished. The failed test was a public embarrassment, but within the deepest levels of Sentinel Shield, it was a seismic event. It triggered a mandatory, independent review by a red team of scientists and engineers from outside the program's direct chain of command, skeptics by profession, tasked with tearing the system apart to find its weaknesses. They were given full access, the keys to the kingdom, and they began not with the failed test, but with the successful one. They burrowed into the terabytes of data from the 1984 intercept. They modeled every variable, the temperature of the upper atmosphere that night, the exact density of the ionosphere, the gravitational perturbations from the moon and sun, the minute solar flare activity, even the background infrared noise from the Earth itself. They reran the intercept simulation thousands of times, introducing tiny, realistic variations. What they found, and documented in a cold, clinical report stamped Top Secret SCI, was a truth so damning it threatened to unravel the entire enterprise. The system's crown jewel, the tracking and discrimination algorithm that allowed the kill vehicle to pick the warhead from the decoys, was not a robust, intelligent filter. It was, in essence, a key that fit only one very specific lock. It worked under a single, exquisitely narrow set of atmospheric and orbital conditions. The algorithm assumed a specific atmospheric density at the intercept altitude, which affected the drag and therefore the trajectory of the lightweight decoy balloons differently than the heavy warhead. It assumed a precise background thermal profile against which the warhead's heat signature would stand out. It assumed a known stable attitude of the target cluster. The conditions on that miraculous night in 1984 had been, by a quirk of celestial mechanics and terrestrial weather, a near-perfect match for the algorithm's hidden assumptions. The upper atmosphere had been unusually calm and cold. There was minimal solar wind activity to create electronic noise. The target cluster had deployed in a textbook-perfect configuration. Nature, in effect, had handed them a laboratory in space. The system hadn't triumphed over chaos, it had been the beneficiary of a cosmic coincidence. The Red Team's report laid it out with devastating clarity. In real combat, those conditions would almost never occur. A nuclear attack could come in summer or winter, during a solar storm or geomagnetic calm. The Soviets would not deploy their decoys in a predictable, stable manner. They would spin them, tumble them, cluster them around the warhead. They might even deploy warheads from their boosters on depressed trajectories, changing the entire thermal and radar signature profile. The algorithm, the very brain of the defense, was tuned to a reality that did not exist outside of a carefully constructed test. The first test had succeeded not because the system's invincibility, but because nature had accidentally cooperated. The second test failed because reality had reasserted itself with a vengeance. The software glitch was merely the first obvious crack in a foundation that was fundamentally flawed. The system was not adaptable. It could not learn. It could not cope with the fog of war translated to the scale of orbital mechanics. It was a prodigy that could solve one specific, incredibly difficult problem, but flunked any variation of the test. This revelation created a quiet crisis. To admit this flaw was to admit that the tens of billions of dollars spent and the promised future of security were built on a statistical mirage. The military-political machine, now heavily invested in Sentinel Shield as both a strategic asset and a political symbol, faced a dilemma. They could go back to the drawing board, a process that would take another decade and untold billions with no guarantee of success, or they could attempt to manage the flaw, to design tests that subtly recreated those perfect conditions to keep the illusion of progress alive while searching for a more fundamental fix in the background. The choice, made in closed-door hearings and secure conference rooms, was almost preordained by the inertia of such a vast undertaking. The flaw was classified at the highest level, discussed only in elliptical terms. Testing continued, but now with an unspoken understanding. The goal was not to stress the system to its breaking point, but to carefully shepherd it towards demonstrations it could pass. The bullet hitting a bullet had been revealed as a trick of light and timing, a magic act that required a rigged stage, and the magicians, bound by patriotism, funding, and fear of the alternative, had no choice but to keep performing, hoping the audience would never see the wires. The Red Team's report on the algorithm's narrow viability was a devastating blow, but it only addressed one layer of the nightmare. As they continued to dissect Sentinel Shield's architecture, they turned their attention to its foundational premise, discrimination. The system's entire maitre d'etre was predicated on a simple, fatal assumption that it could tell the difference between a real warhead and a fake one. It was a task that proved to be the Sisyphus stone of ballistic missile defense. The Soviet offensive machine was not a static force. While American engineers in secure labs were perfecting their kill vehicle's sapphire lens and microthrusters, Soviet physicists in closed cities like Arzamas-16 were engaged in a parallel and in many ways simpler endeavor: deception. Their goal was not to hit a bullet with a bullet, but to make a single bullet look like 100. By the mid-1980s, Soviet ICBMs like the monstrous SS-18 Satan were already deploying advanced countermeasures. The technologies were elegant in their lethality. After the booster burned out and the post-boost vehicle, the bus, released its deadly cargo, it didn't just let go of the warheads. It performed a final, malicious act. It would inflate dozens of metallic mylar balloons, each precisely the same size and shape as the conical re-entry vehicle. Some were left empty. Some contained small, radio-reflective metal shrouds. Others were coated with materials that mimicked the thermal properties of an ablative heat shield. This created a threat cloud of identical-looking objects, a hall of mirrors in the vacuum of space. Further complicating the picture was chaff, clouds of fine radar-reflecting wires, and the bus itself, which would often break up into large, confusing fragments. To the eyes of a radar, and more critically to the fledgling infrared seeker of a kill vehicle, this swarm presented an insoluble puzzle. The warhead, heavy and dense, followed a slightly different ballistic path through the very last wisps of the exosphere compared to the lightweight balloons. This was the discrimination signature Sentinel Shield was built to detect. But the Soviets knew this. They could design balloons with different internal pressures or attach small cold gas thrusters to make them wobble or drift in ways that mimicked a heavier object's behavior. They could cool the warhead or heat the decoys. It was a game of cosmic chess where the offense could change the rules with every move. The Red Team simulation, using the best intelligence on Soviet countermeasures, produced a chilling result. When faced with a realistic threat cloud from a single SS-18, which could carry 10 warheads and 100 decoys, the Sentinel Shield discrimination algorithm failed over 90% of the time. It would either lock onto a decoy or, more often, become so confused by the multiple returns that it would default to a safe mode and refuse to commit to any target at all. The kill vehicle would fly through the swarm like a blind man in a snowstorm, its sophisticated brain paralyzed by an abundance of false choices. This was the deeper, more profound flaw that no software patch could fix. The system had been designed and tested against a theoretical, compliant enemy. It had been built to fight the missile threat of the 1970s, not the one evolving in the 1980s. The enemy in all the successful simulations was a dumb, inert object on a predictable path. The real enemy was clever, adaptive, and had spent decades and rubles ensuring its weapons would survive. The Pentagon, in its relentless drive for a technological silver bullet, had built a miracle weapon for a theoretical war. In a real nuclear exchange, Sentinel Shield wouldn't just fail, it would fail expensively, firing its precious, limited inventory of interceptors on wild goose chases, leaving the skies undefended while the real warheads descended unimpeded. Second, the computing. The battle would be won or lost in microseconds and millimeters. Once a target was identified, the system had to calculate its future position, plot an intercept course for the kill vehicle, and transmit constant updates, all while both objects were moving at hypersonic speeds. The computers of the early 1980s were monstrous, room-sized machines that operated at a fraction of the speed of a modern smartphone. The software had to be flawless, not 99% accurate, but 100%. A single line of errant code, a rounding error in a calculation, and the interceptor would miss by miles. Engineers developed new programming languages and built redundant systems, but they were working at the very limit of contemporary technology. The brain of the kill vehicle itself was a marvel of miniaturization, but it was also brittle. It could handle the scripted scenario of a test, but could it adapt to the chaos, the electronic jamming, the unexpected maneuvers of a real nuclear exchange? Which brought it to the third and most breathtaking pillar, the kill vehicle. This was the tip of the spear. Engineers described it with a mixture of reverence and anxiety. It was, they said, a guided bullet trying to hit another bullet at 15,000 miles per hour. But that analogy was too simple. A bullet is dumb. This was a smart bullet. It weighed only about 140 pounds and was roughly the size of a garbage can. In its nose sat the infrared seeker, a delicate window of sapphire, cooled by a miniature cryogenic system to near absolute zero to increase its sensitivity. Behind it was the guidance computer and a ring of tiny solid-fuel thrusters. There was no explosive. Its destructive power was purely kinetic energy. At the moment of impact, the energy released would be equivalent to a heavy truck traveling at 600 miles per hour, concentrated on a point the size of a coin. It would vaporize the warhead in a cataclysm of plasma and shrapnel. But its sensitivity was its Achilles heel. The thrusters were so fine they could alter its course by mere inches per second, but they were easily disrupted. The seeker could be blinded by nuclear detonations in space or by simple debris. The whole assembly had to survive the violent shudder of launch, the vacuum of space, and the extreme temperature swings from blistering sunlight to deep shadow. It was a watchmaker's instrument bolted to a skyrocket. Sentinel Shield demanded perfection, perfect timing, perfect calculations, perfect conditions. It was a system designed for a laboratory, a clean, controlled, dualistic world of go or no-go. But the Cold War was not a laboratory. It was a murky, gray, and terrifyingly imperfect world of fog, friction, and fallible humans. The Soviets were not static. They were dynamic, clever, and relentlessly dedicated to ensuring their missiles would get through. For every advance in defense, they worked on 2 advances in offense: more warheads, better decoys, faster-burning boosters, maneuvers in the terminal phase. The 1984 test had been a stunning proof of concept. It showed that, under ideal circumstances, a hit was physically possible. But it was a single choreographed dance in an empty ballroom. It did not answer the fundamental question: could this system work in the blinding, deafening, chaotic inferno of a real nuclear attack, when the skies would be filled with hundreds, perhaps thousands of warheads and a myriad of deceiving ghosts, when the radars would be screaming with noise, and the very electronics might be fried by the electromagnetic pulses of prior detonations? The success at Kwajalein had bought Sentinel Shield political capital and continued funding. But in the quiet, windowless rooms where the real work was done, a more sober understanding was dawning. They had built a masterpiece that could perform a specific, beautiful trick. But the war it was meant to fight would be ugly, messy, and utterly devoid of the perfection it required to survive. The flawless first test was not the beginning of an era of invulnerability. It was, though few dared admit it at the time, the high watermark. The control room at Kwajalein Atoll 2 years later was a monument to confidence. The stark, functional space had been upgraded. New consoles with brighter screens hummed with a sense of purpose. A large centrally mounted monitor displayed a digital map of the Pacific, its glowing lines tracing the planned trajectories from Vandenberg to the intercept zone. The atmosphere was tense, but it was a professional tension, laced with expectation. The triumph of 1984 was no longer a miracle, it was a precedent. The team had done it before, the system had worked. The machinery of Sentinel Shield had been refined, its software updated, its hardware tested. This was to be the second public demonstration, the next step in proving the reliability of the concept. The world was watching again, but this time the narrative was set. America was perfecting its Astrodome. The target missile, another Minuteman I, lifted off from Vandenberg at 0400 local time. Its fiery ascent was a familiar spectacle, a beautiful, terrible rose blooming in the California night. Data streamed into Kwajalein, radars locked on, the target cloud deployed. This time, the decoys were more sophisticated, a subtle increase in complexity to simulate incremental Soviet advancements. In the control room, the mission director, a seasoned Air Force colonel with a voice like gravel, provided calm commentary. Track is nominal. Threat cloud is dispersed. All sensors are green. It was all going according to the script. The order to launch the interceptor was given with the cool certainty of a practiced routine. At Kwajalein, the night once again shattered with the thunder of rocket engines. The Interceptor, a newer model with a supposedly more robust kill vehicle, climbed into the pre-dawn sky, a streak of furious light chasing the ghost of the Minuteman. The first stage separation was a clean, bright flare on the tracking cameras. The second stage ignited. So far, it was a mirror of the first test, a flawless recitation of a proven sequence. In the control room, the silence was absolute, then shattered by a low guttural curse from a console operator. "We've lost the KV. No guidance, no commands. It's dead." The mission director's voice, previously so steady, tightened. "Confirm that. Are we receiving any telemetry at all?" "Negative, sir. We have housekeeping data only. The guidance computer is non-responsive. It's frozen." On the big screen, the two trajectory lines, the targets and the interceptors, which were meant to converge in a violent kiss, began to diverge. They slid past each other with a kind of serene, mathematical indifference. The distance between them grew, 10 kilometers, 100, 500. The target cluster, unmolested, continued on its path until it streaked harmlessly into the atmosphere and burned up over an empty stretch of ocean. The kill vehicle followed a lonely, useless arc downward, its delicate sensors and precision thrusters melting into slag as it re-entered the atmosphere 900 kilometers away from its intended point of glory. The post-mortem was a brutal exercise in forensic engineering. The data was pored over by teams working in shifts under the harsh fluorescent lights of secure laboratories. The fault was traced not to the rocket, not to the sensors, not to the cryogenic cooler, but to a handful of lines of code in the kill vehicle's onboard computer. During the high-stress moment of transition from external to internal guidance, a software process tasked with managing the flow of sensor data attempted to write to a protected area of memory. The computer's operating system, designed for absolute reliability, threw a fatal error. Instead of resetting the process, the entire system locked up, a digital heart attack 3 seconds into its autonomous life. Technicians on the ground who had sweated over every resistor and solder joint pointed to the software. It was a glitch, they said, an anomaly, a 1 in a million timing error that could be patched. The contractor responsible for the code argued that the specifications had been changed too late in the cycle, that the integration testing had been rushed to meet the politically important test date. Command at the Pentagon blamed the deadlines, the pressure to show continued progress to Congress and the public. But in the classified reports, a more unsettling truth began to whisper. The software hadn't failed randomly. It had failed because it was asked to do something in a slightly different sequence than it had in the perfect first test. A millisecond difference in the handoff from the ground radar. A tiny variance in the temperature of the kill vehicle's chassis affecting a crystal oscillator. The Pacific Ocean, on a chill October night in 1984, was a vast black mirror reflecting a sky dusted with indifferent stars. At the Kwajalein Atoll, a speck of American-controlled land in the Marshall Islands, the air was thick with salt and tension. Technicians in a cramped, dimly lit control bunker hunched over green-glowing consoles, their faces etched with a fatigue born not of hours, but of years. They were waiting for a signal from Vandenberg Air Force Base, 4,000 miles to the east on the California coast. In a silo there, buried deep in the earth, a Minuteman I intercontinental ballistic missile, a weapon designed to end cities, was being prepared for a unique mission. It was not aimed at any enemy capital. Tonight, its sole purpose was to be destroyed. This was the culmination of a secret endeavor that had consumed billions of dollars and the careers of a generation of scientists. It was called the Homing Overlay Experiment, part of the broader, more clandestine Sentinel Shield program. The theory was audacious, bordering on science fiction. to defend the continental United States from a Soviet nuclear attack by intercepting the warheads in the cold, airless void of space. Critics called it a fantasy. Physicists argued it violated the laws of probability. To hit a warhead screaming from the edge of the atmosphere at 15,000 miles per hour with another object moving at a comparable speed was, they said, like trying to shoot a bee with a bullet while both were in a hurricane. Yet here they were, at the edge of the impossible. The voice over the comms from Vandenberg was calm, steady, T-1 minute, all systems nominal. In the Kwajalein bunker, the focus shifted to their own weapon. This was the Interceptor, a two-stage rocket tipped not with an explosive warhead, but with a sophisticated, delicate package of sensors, thrusters, and computers known as the Kinetic Kill Vehicle. It was a masterpiece of miniaturization, a mechanical hawk. Its brain was a prototype computer with less processing power than a modern digital watch, programmed with algorithms meant to predict the unpredicted. Its eyes were an infrared seeker, cryogenically cooled to spot the faint heat signature of a warhead against the absolute zero backdrop of space. Its destruction would come not from blast, but from impact. The sheer, unimaginable force of a direct collision, converting momentum into obliteration. Vandenberg, launch commit. The countdown hit 0. In California, the earth trembled. With a roar that split the coastal silence, the Minuteman erupted from its silo, a pillar of fire punching into the night sky. It arced over the Pacific, a man-made star ascending. For the team at Kwajalein, the data streams began to flood in. Radars at the atoll and on tracking ships painted the target. It was a ballet of telemetry, a symphony of ones and zeros conducted across thousands of miles of ocean. The Minuteman's dummy warhead, along with its booster and a cluster of decoy balloons, deployed into the pre-dawn blackness. They formed a small constellation of death, a microcosm of a Soviet salvo. Kwajalein, launch commit. The order was given. From the atoll, the interceptor leapt skyward, a second answering flame. It climbed, shedding its stages, a dart aimed at a point in space not yet occupied, a rendezvous calculated by banks of whirring computers. For 3 long minutes it was a pure rocket, following a pre-programmed path. Then, at an altitude of over 100 miles, where the sky is forever black, the final act began. The shroud protecting the kill vehicle blew away. It was on its own now, a solitary hunter in the infinite dark. In the control room, silence fell, broken only by the hum of machines and the ragged breathing of men. The infrared seeker on the kill vehicle woke up. It scanned the freezing emptiness, searching for the telltale warmth of the warhead amidst the cooler decoys. It was a moment of terrifying vulnerability. The system had to discriminate, to choose, to think, a blip, then another. The algorithms wrestled with the data. Which was the warhead? Which was a balloon? Then it locked. With a series of tiny, precise puffs from its lateral thrusters, microscopic adjustments measured in centimeters per second, the kill vehicle oriented itself. It was no longer just a projectile, it was a guided entity, homing in with a terrifying mechanical purpose. On the screens in Kwajalein, the two trajectories, the target's calculated path and the interceptor's real-time course, began to converge. The lines inched towards each other, a digital enactment of destiny. Acquisition confirmed, terminal guidance active. The closing velocity was over 7 kilometers per second. There was no sound in space, no flash of explosive. The only evidence of success or failure would be a sudden disappearance. The radar screens showed 2 bright contacts. Then, in an instant, they showed a blossoming cloud of debris, a silent fireworks display of shattered metal and vaporized components. For a heartbeat, nothing. Then the room exploded, not in fire but in pure, undiluted euphoria. Engineers, military officers, and scientists leapt from their chairs, embracing, shouting, weeping. They had done it. Against all odds, against the scoffing of the scientific establishment, they had achieved the physically improbable. The kill vehicle had struck the dummy warhead with, what the data would later confirm, was near-perfect precision, a direct hit. It was a technological miracle, a David and Goliath story written in mathematics and rocketry. The video, declassified and released to the public weeks later, showed the stark, mesmerizing imagery, the infrared view of the target, the sudden, swift approach of the interceptor's signature, and then a puff of silent, conclusive debris. For a moment, America and the world believed the paradigm had shifted. Headlines proclaimed the dawn of the Astrodome defense. Editorial cartoons showed Uncle Sam holding a high-tech shield. In the context of the Cold War, where mutual assured destruction was the grim, accepted doctrine, this was revolutionary. It promised not just defense, but invulnerability. The nuclear missile, the ultimate weapon for 4 decades, had seemingly been rendered obsolete by a guided bullet in the void. The success was so clean, so absolute, it felt like magic. But magic, in the realms of physics and warfare, is often just the prelude to a harder, colder reality. The triumph of 1984 was not a spontaneous breakthrough, but the public-facing crescendo of a decades-long symphony of secrecy, ambition, and astronomical expense. Its roots twisted back to the dawn of the nuclear age itself. The moment the first atomic bomb fell on Hiroshima, a parallel quest began, to find a defense against it. Early ideas were the stuff of fever dreams, giant death rays, particle beam weapons, even plans to detonate nuclear bombs in the upper atmosphere to create radiation belts that would fry incoming warheads. They were desperate concepts for a desperate time, all hamstrung by one immutable fact. Stopping a weapon moving at the speed of a meteor was a problem of almost unimaginable difficulty. The program that would eventually gestate the 1984 test was born in the labyrinthine bureaucracy of the Pentagon, under a veil of classification so dense it had no single name. To those few with the clearance to see its entirety, it was known as Project Sentinel Shield. It was a child of the Reagan administration's Strategic Defense Initiative, Star Wars, but its technical heart had been beating since the 1960s. While Reagan spoke publicly of a grand space-based shield that would make nuclear weapons impotent and obsolete, the engineers of Sentinel Shield were focused on a more terrestrial, but no less daunting task: the exo-atmospheric intercept. The system's architecture was a house of cards built on the edge of the possible. It rested on 3 precarious pillars: sensing, computing, and impacting. First, the sensors. To hit a warhead, you must first see it, and see it clearly amidst a storm of deception. A Soviet ICBM launch would not present a single neat target. As a missile climbed through space, its final stage would release not just the warhead, but a host of countermeasures: lightweight decoys, balloons that could mimic the radar signature of a warhead, chaff clouds, and possibly dozens of cheap fake warheads. This galaxy of objects was the threat cloud. Picking the real warhead from the field of junk tossed into a hurricane was like identifying the real diamond from a handful of glitter tossed into a hurricane.